All right, so now we're on to validity conditions, and I took the checklist that I've shown you before, but it's from the reading in chapter 4, which is, it might be a little bit harder to read this, but I took those validity conditions out of a checklist, and this is for linear regression. Why do we have validity conditions? If you remember back to MA 103, every model had assumptions, and if those assumptions were invalid, then the model could not probably be extrapolated beyond these. Not always, but you're now going out of the four corners of the assumptions. Statistical theory-based tests have similar kinds of assumptions behind them. For example, we might be assuming that if something follows a normal distribution, then I told you there's a function, there's an actual function, it's got an exponential in it, and I know everything about that function. So everything relies on this house of cards that's based off of my assumption that the data was spread like a normal distribution. So when these assumptions are not valid, they're not satisfied, then the application to this theory-based test is flawed. And this is extremely important because today we have high-functioning statistical packages that are very easy to use. You can push some buttons, but it's still up to you to decide if these assumptions are valid or not. Some of them actually have it pre-built inside the application, so and at some level. But it makes it very easy to push these buttons and get a table and then put the table out, even if the assumptions are not validated. And so this is important before someone uses linear regression right and left to check these things. So we're going to start with the first one. I want to make a residual versus predicted plot. And I want to show that it doesn't show any pattern inside it, like curvature or linearity. So how do we do that? Well, the first step is I need a predicted column. If I have predicted values on the x-axis, I need a predicted column. And for that, I need the model. And so I'm back to predicting hand-release push-ups. I'm going to have you do the same thing with IOCT data. We were predicting, I think, the scores and the time from IOCT. You already have that hopefully saved. You hopefully didn't keep it as ACFT. But you have this model, and now you translate it the way we did on the board. So we did all this. I walked around the room, make sure everybody could do this, to transfer these coefficients on these estimates as the coefficients of the predicted model. So I name it exactly what I just don't call it predicted. It's HRPU predicted because it's the hand-release push-ups that are predicted from this model. So I'm using the word predicted here loosely. I mean, these are not really the way we write things theoretically, but for right now, I'm going to keep it as where these came from, and it's easier to think of it that way. So now I have this model. I had to make a few columns. The first thing is that gender, this is going to come up for many of you, it didn't like going back to just the male-female version, when it had it in the column as gender, so I had to assign it the value 1 if it was male and 0 if it was female. So I had to make a gender column, and I just used a little g for gender, and it makes a new column. Then I made another column for the predicted. It's just my model. So this has to come first, this has to come second, and so I put in my model that I got from the linear regression, and then I had to make a residuals column. So I actually did this in class with you. There's already a video on it, but I just took the HRU raw was the actual hand-release push-ups, so your IOCT time or whatever you used would be here, and your IOCT predicted would go here if you were doing the same thing. And then I always check, because I told you I inoculate myself against myself. I know I'm a messy person, so I go back and double check. So I went back to the data file and checked that when I did these mutate commands, that I actually had in the data file now a gender column with 1s and 0s, and I didn't screw it up somewhere. If there was a bunch of 0s everywhere and no 1s, I know something messed up. And it gave me this predicted value here, and you see, I can even see the males have higher predicted HRPUs just from looking from this little screenshot. So everything looks as if it should be. Now I make a plot of the residuals versus the predicted. And let me see, I have that, let me see, as text, but so I put a line in there too, and I gave you the code for this. That line should not look like it has a trend in any way. Actually, in my obesity field, they call this trend in the error. They're like, oh, look, Dr. Thomas, there's a trend in the error. That's not good for us. You don't want any trend. You want this line to be as flat as possible. And it does look flat. Here's the code. I just gave it to you as a snip. It's the same ggplot. The x would be the predicted. The y would be the residuals or the error. This geom smooth method equals lm puts that blue line in there so I can see it. And I notice I'm very neat about my actual lines. I actually met today with Corby Martin, who's a psychologist, who used to really bug him that my graphs were messy and that I didn't line everything up. And I would love to actually have told him today that, hey, you should see this transformation, because I'm very careful now to say that my x-axis is, my y-axis, I change all those things. I didn't have a check mark. They have these weird symbols inside PowerPoint, no check marks, but I put in a thumbs up for, yes, I've got the first one. The second one, the responses can be considered independent of each other. That has to do with your data. This comes from your knowledge of the data. It's possible that the data is not independent. I was using strength and max deadlift. Well, if someone did poorly on the max deadlift, it might affect, because it comes first, it might affect what they do on the hand release push-ups, and therefore that data is not independent of each other. That could be the case. It's your call. I'm going to say that whatever they did on the hand release push-ups is independent from anything else. And each person is independent on everybody else too. So if I'm looking at, somebody's not looking over at the guy next to him doing 36 hand release push-ups and going, oh, I can't do that many, and now I'm really screwed because I don't feel very good about myself. So that's the independence assumption. The histogram of the residuals, so you have to explain yourself when you go there why that is independent of each other, why each one of those dots in your plots are independent of another dot. The histogram of the residuals should be symmetric, and I was kind of surprised the hand release push-ups, the residuals they're centered around 0 and they look like a bell curve. That's not usually typically the case. That is so perfect looking, but it looks nice here. And the command is this histogram of the error. So that looks like it's satisfied. The final one is that the residuals versus the predicted graph shows a constant width. We call that equivariance. That doesn't look quite the case. It looks like this has more variance than this. It's up to the beholder to make that decision. I would not say that's exactly the case here. The males seem to have higher variance. So if you do come up with, one of the validity conditions is not valid, you have to say it, and make sure, you're still going to have to do all the linear regression modeling, but before that you say, I checked all these validity conditions, and this one, here's the graphs, and this one doesn't seem to hold. So that's it for validity conditions, and now I have an in-class assignment, the one that you have for all those questions about residual plots and looking at those things, or for how to make a conclusion after you have the graph. It's not how to make the graph. And when you actually go to the R code and make the graph, you always find that that's a little bit difficult. So what I'd like you to do is go through the concepts first, finish this in-class assignment. Once you're done with that in-class assignment, take the IOCT data and recreate the code snippets to make the residuals. I'm going to send this PowerPoint out so you can readjust that in your code. You already have the code and you already did the first part of it. So now you're going to do the second part, checking the validity conditions. So depending on time, get through that. The more you get through, the better.